In this video, we continue with section 4.3, and we're going to do a couple of examples of how to use the first derivative test. So consider the function f of x equals 3x to the 4 minus 4x to the 3 minus 6x squared plus 12x plus 1. So if we do f prime is going to be 12x cubed minus, and we're going to have 12x squared minus 12x plus 12. So clearly we can factor here on 12. And we're going to get x cubed minus x squared minus x plus 1. So it looks like I can factor somehow more things. So let's try and group things. Let's factor x squared from this too. So if I factor x squared, I'm going to get x minus 1 here. And if I factor a minus, notice that I get x minus 1 here as well. So now I get x minus 1 as a common factor, and is x minus 1, and then x squared minus 1. I can actually see this as a difference of squares, and so this is going to be x minus 1, x plus 1, and everything is going to be 12 x minus 1 squared, x plus 1. Now, I'm interested in knowing where this is going to grow, where is the interval with the function is increasing and decreasing. So I'm going to use the critical points as a good point to step. So f prime of x is equal 0 if and only if x minus 1 is equal 0 or x plus 1 is equal 0. This is the two options that give me 0 from here. So you're going to get x minus equals 1 or x is equals minus 1. Okay, and so now that's going to influence the way that I'm going to check the real line, because notice that those are potential candidates to be maximums or minimums. So I expect that there are going to be changes around those points. Now, I'm going to split the real line from minus infinity to infinity as minus infinity to minus 1 to 1, and 1 to infinity. And now what I want to check is what is the sign of the derivative in those points. For that, I'm going to take a number. And so let's say over here I can take a number x equals minus 2. Over here I can take x equals 0, and over here I can take x equals 2. So notice that if I compute those numbers, f prime of minus 2 that's going to be equals to 12 minus 2 minus 1 squared and minus 2 plus 1. This is going to be positive, this is positive, and this part is going to be negative. That's what matters. So you can see that this is less than 0. And so here I can check that in this position f prime is less than 0. Notice that I can generalize the idea that that in all this interval f prime is less than 0, because I don't have any other critical point, and the critical point are going to be places where there's a change between between the signs, right? This is f prime less than 0. I don't have any further 0 down here, so this is not going to change to positive suddenly. Okay. Now, if I check f prime of 0, notice that that becomes 12, 0 minus 1 squared, which is positive, and 0 plus 1, which is positive. So this is positive. And now over here we have that f prime is positive. So that this means now here all this function f is going to be growing. Here f is going to be decreasing. Here f is going to be growing. And if I check f prime in 2, then you notice that this is 12, 2 minus 1 squared, which is also positive, and 2 plus 1, which is also positive. So f prime is positive here, and f is growing again. Now, we're going to talk about or make a summary of intervals where it is increasing. So increasing, we can talk about being minus infinity to minus 1, union, we can talk about being minus 1 to 1, union with 1 to infinity. So we notice that this critical point here is not going to be either maximum or minimum because there is no change between them. But the decreasing is from minus infinity to minus 1. And notice there is a change from the function decreasing to increasing. So x equals minus 1 is likely to be a minimum value. Now let's take a look to a second example. Consider f of x equals x squared minus 2 log of x. So in here, f prime of x is going to be 2x minus 2, and the derivative of log of x is 1 over x, so 2 over x. I can rewrite this as 2x squared minus 2 over x, or 2x squared minus 1 over x. Okay. Clearly, for critical points, we're going to check f prime of x is equal 0, which is going to lead to 2x squared minus 1 being 0, which is going to lead to x minus 1, x plus 1 being 0, since 2 is never 0, and that's going to lead to x equals 1 or x is equals minus 1. Now, we can also have for critical points the case where f prime of x do not exist. So the case where f prime of x do not exist is where the denominator is going to be 0. Okay, so we have 3 main critical points. Now we split the real line between those 3 critical points. So we have minus 1, we have 0, and we have 1. So that's going to split our real line in 4 different regions. And we can take different points to check how they behave. So the points I'm going to take are going to be minus 2. And here I'm going to take minus 0.5, 0.5 here, and 2. And that should give me enough information of how the signs are. So f of minus 2, f of minus 1, sorry. F of minus 2, f of minus 0.5, f of 0.5, and f of 2. Now again, notice that I don't need the value, I just need the sign. So I can very quickly try and check what's going to happen. So this is a negative number, and I'm going to get 2, and over here I'm going to get a 4 minus 1. So this is very positive, but over minus 2, that's going to be a negative number. So I can know that f prime here is going to be negative. And just remember, since we're finding the zeros and we're finding the places where it doesn't exist, then we can consider that this whole area is going to be negative since we don't have a transition point. We don't have another 0. Okay? We're using the transition points as the intervals that we pick to know where the functions are increasing or decreasing. Now, if I do minus 0.5, I'm going to get 2, and this is minus 1/2, so minus 1/2 squared is 1 over 4 minus 1. This is clearly negative, and over another negative, this is going to be positive. So over here, f prime is positive. Similar situation will happen with the 0.5. since it's not affecting too much of the sign. But over here we get 1/4 minus 1, and over here we get 0.5. So this is a negative on top, positive below, so everything is going to be negative. And finally, f of 2 is going to be 2 and 4 minus 1 over 2. So this is positive, below positive, so we get a positive as well. So now here we have the transition. This is f prime is negative and f prime is positive. So notice overall this means decreases here, increases here, decreases here, and increases here. So we have the intervals for increasing. So the increasing interval is -1 to 0 union with 1 infinity, and the decreasing intervals are going to be -infinity to -1 union 0 to 1. Now notice that with the first derivative test we can talk about what values are here. So likely x equals -1 is a minimum, and x equals 0 is a maximum, and x equals 1 again is going to be a minimum. Notice we have this kind of shape over here going on. If I think decreases, increases, so it's doing this. If I have this here increases, decreases, and it's likely that we have a peak because the derivative does not exist in there. And over here we also have a minimum. So we have a situation like this. And that is the examples for the first derivative test.